Hey physics class, how's it going? Last video for these two body problems for kind of this week. Hopefully a little bit of an easier week for you guys in the sense of this week and next week. I want to kind of wean down for those last 2 weeks and talk about the two bodies. I didn't want to start anything new in the last week, so kind of stretch out this last little bit a little more than usual. So hopefully that works out. We have 2 questions here. In this question we have what's called actually a multi-body question, where there's 3 different objects. 2 of them are on the sides, 1's in the middle. This is very similar to a question that's on your worksheet. This is not the same numbers though, so I'm not using the exact same numbers. There'll be an answer key for that worksheet anyways. That'll be popping up there either today, which is Tuesday, or really good Thursday. Sorry, I'm not in school Wednesday at all, so but that'll come up there, the answer key. So this is very similar though. We have a mass of 10 in the middle, mass of 8 over here, mass of 14 over here. I don't know why I didn't put a mu. There's a mu of 0.4. All right, let's put mu of 0.4, and then it's just asking you to find what is the acceleration of this whole basically scenario, because again, they're all tied to each other. I can't just say it's the acceleration of just this. All 3 of these are going to move in the exact same fashion. Okay, so that's question 1 here. Question 2, we have somebody falling or holding onto a rope over a cliff. Someone else is holding them up and digging their heels kind of into the ground. So it says, what is the force applied needed to pull the person up? So we have a mass of 60, a mass of 70. That shine is right in the way, man. Let's go. Mass of 70 kilograms. There we go, that's a lot better. And there's a mu of 0.25. So basically we're looking though for a force applied. What is the force applied needed from this person to actually hold this person up and then slowly bring them back up? So let's go through these 2 problems. In this problem here, first thing, find force of gravity for all 3 of them. So just their mass times gravity for each one. All right. So I'm going to put that down for each one. We have a force of gravity right here of 98. Where's my answer key? Here we go. We got a force of gravity for this one. Force of gravity of 137.2. Again, mass is 14 here. Mass is 8 kilograms here. We have force of gravity of 78.4. Oh wait, so there's our setup. I know I'm kind of getting out of the screen a little here. So I mean, this kind of makes sense in the sense of 14 kilograms, 10, 8. Which way do you think this is going to move? It's going to move in the 14 kilogram. It has the most mass, which means it's going to have the most force in the downward motion. Okay, so 137, 78, and 98. Now, are we actually going to use this 98 in the sense of a force going either way? No, you're not going to use the force of gravity, because again, force normal is exactly the same pushing this thing up. So that actual force gets kind of canceled out. But because there is friction, we can see how much this object in the middle is going to slow down the actual acceleration. So force of gravity is 98. That means force normal is also 98. There's no angles. So force of gravity, force normal are the same for this one. All right. We have to find force of friction, which is, again, going back to what we've been doing for quite a while, is just the mu times force normal. All right, so let's find out what force of friction is here. Force of friction equals 98 multiplied by 0.4. I think that gives you 37 point something. 30, where is it? Where is it? 39, sorry, 39.2. Sorry, 39.2. Okay, so that's force of friction. All right, so now we have all the force that we need. We have 137.2 here. I know it's kind of hard, again, to see with that shine. Let's move down a little. Force, gravity, 137.2. That's the force of gravity here. It's 78.4, and then we have force of friction. So basically, how we're going to find a force net, I'm going to do some black. I'm going to find my net force, and I'll give myself a little more space here. Force net is going to be your largest force minus kind of what's opposing it. Well, we have this force that's pulling in the opposite direction. So we're going to go this minus this because they're going opposite directions, as well as minus our friction, because friction is always slowing it down. Okay, so 137.2, all right, minus 78.4, as well as minus 39.2. In the end, I get a net force of 19.6, positive 19.6. Okay? So there's my force net, is 19.6. All right, so that's, again, this minus this force of gravity as well as force of friction. Now, if this ended up being negative, where I took the largest force of like the actual force gravity on these objects, and I minus it from the other one and minus it from friction, like let's say instead of friction here being 39.2, let's say it was like 70. So if I go 137 minus 78 and 70, it's going to give me a negative number. That would mean that friction is winning and that these objects actually wouldn't be moving. They'd be in some kind of what we call like, they'd be in like a harmonic state of no movement because of the friction and how much friction there is compared to the other two forces, just nothing would be moving. It's in a stable kind of state. But because I do have a force net, as in like something is winning against the other two, we are going to have an acceleration. So last thing is acceleration equals 19.6 divided by not just 14, not just that object. Remember, mass total, all the masses together. If you add them all up, you get 32. 32. So acceleration ends up being, I don't know, 0.6. 0.6 meters per second squared. That's how fast all of these objects are kind of moving either down or to the right or up, but like basically in this direction, okay? So there's that answer. All right. Again, anytime you guys have any questions, please ask me. I'm basically always in school. My phone's usually pretty much glued to me, so I can answer questions anytime you want. Last question for our helpful videos here. What force applied is needed to pull up this person? So not too many actual variables here. There's only two people, so a two-body problem. Again, let's just start with force of gravity for each one of these. So we have a mass of 60, mass of 70 kilograms. So for this person at the bottom, times by 9.8, I get force of gravity equals 588. This person, we're going to need a force applied eventually, but let's figure out the force of gravity first. Force of gravity equals 686. 686. Oh wait. Now that force of gravity is just what's holding this person, like how much force this person has on the ground. Force normal is canceling that out in this scenario. Like this number does nothing for the rope. Okay? So we need to find a force applied, and it's not just going to be 588. I know this person is fully like falling with a force of 588. But because you are on the ground and your feet are touching the ground, there's going to be friction between you and the ground. So the friction is going to help you hold this person up. You don't have to do all of that force applied to make up that 588. So force normal is the same because we're on a nice even spot here, so 686. And let's find what friction is. Friction equals 686, that force normal, times 0.25. 0.25. Okay. So when I go with 686 times 0.25, the coefficient, I get an answer of 171.5. 171.5. All right. Well, now we have no more forces in the sense of like, I have to figure out the last force applied, which is going to be right here. What is that force applied? Question mark. So what is that force applied? But I have nothing else to kind of go with. So this person has a force falling down with 588. Friction is slowing this person down though. Okay, friction is going to be going in this direction, right here. That is force of friction. All right, so right there, that's going to be slowing this whole thing down. So the question is, what force applied is needed to pull the person upwards? Well, the nice thing is, if you are going to apply a force, it has to be like, basically we're going to take this, minus it from the friction, because that's what's slowing down, and then anything over that force applied is going to actually help this person go up. So let's minus these two, and that's kind of our last step. We have 588 minus 171 point, I forgot one in there, 171.5. And what do I get? I get a net force of 416.5. So if you were to pull with exactly 400, I'll get back on the screen. If you were to pull exactly with 416.5, basically this, like, you would go nowhere. You stop this person from falling, but you wouldn't be lifting them up. So basically anything over that, anything over the 416.5 would start to pull this person up. Okay? And so that's how you would find this kind of question, which is very similar to, I think, the second or third last question on the back side of your worksheet. All right, class, if you have any questions at all, please let me know. Thanks so much for the videos. Have a great day.